Hi, and welcome back to another LeetCode video. Today we're looking at the daily problem, which is 3147. Take maximum energy from the Mystic Dungeon. It's rated as medium, and yeah, let's get into this and try to solve it. I have not tried to solve this before. Okay. So in a Mystic Dungeon, n magicians are standing in a line. Each magician has an attribute that gives you energy. Some magicians can give you negative energy, which means taking energy from you. You have been cursed in such a way that after absorbing energy from magician I, you will be instantly transported to magician I plus K. This process will be repeated until you reach the magician where I plus K does not exist. In other words, you will choose a starting point and then teleport with K jumps until you reach the end of the magician's sequence, absorbing all the energy during the journey. You are given an area energy and an integer K. Return the maximum possible energy you can gain. Note that when you reach a magician, you must take energy from them, whether it's a negative or positive energy. All right. Constraints. So we have at least one magician, so at least one element in our energy array. The values of energy can be positive or negative. And we have K, and K is guaranteed to be never larger than the length of the array of magicians. All right. So this sounds like, let's look at an example. So this is an energy array and a step size of K. Right, so output 3, we can gain total energy of 3 by starting from magician 1, absorbing 2 plus 1. So this would be magician 0, this would be 1, and then we absorb the energy, which is 2, then we go 3 steps forward, so 1, 2, 3. So now we hit the 1, and the total energy is 3. What if we go to 5? Well, we get 5 energy. Have to make 3 steps, 1, 2, 3, minus 5, so that's 0. And what if we go here? Then we get minus 10. We can't go anywhere else. If we go here, we get minus 5. And here we just get 1. Okay. But, okay, interesting. So let's just look at the second example. So step size is 2. If we start here, we will get minus 3 as energy. If we start here, we get also minus 3. Only when we go here, we get minus 1 energy, because K is guaranteed to be within the range. So there will always be a result. In this case, the minimum is the result. All right. It's a little weird, right? Because it looks like, so we've solved, this other cube problem with the wizards that were brewing the potions, which was I guess a processing queue type problem. Now, this one, to compute the maximum, that reminds me of a dynamic programming problem. However, it seems like we don't have overlapping sub-problems really. Oh no, we do have. So within so if we iterate through the array at a step size K, right, if we want to compute the maximum amount of energy we can take, we should probably start at the very end, take 3 steps forward or backwards, and then update our sum. It's kind of like a prefix sum, but from the back. So it's like a postfix sum. And when we pick the point where that postfix sum is the largest, but so that we can solve an O of n. And since we have to just try different starting points, namely 3 different starting points from the end, and we will only touch every single element in the queue once, that's still going to leave us with an O of n time complexity and only constant space. We just need to keep track of our postfix sum. So that seems kind of straightforward. So let's try to implement this. So result, always start with the result variable. That's mechanics by now. So result equals 0. And we now have to pick the starting point, but from the end. So for, I guess, end, well, starting point from the end. maybe we should just call it I. In range. And where do we start? We will start at the end of the array, right? So that's range of energy -1, -1, -1. So that would loop over the entire array in reverse order. But we only want to, well, just find the k starting points. So what we have to do is we have to take the length of energy, but minus k. I think that's what we have to do. And because it's guaranteed that k is smaller or equal than length of energy, we should be fine. However, since in a range, the second parameter, the 2, is exclusive, so we have to do a -1 here as well, I think, yeah. I think yes. Otherwise, we would have an off by 1 error. Okay, and now we just compute our postfix sum. Well, we need a second loop that now loops over the energy array starting at I and uses step size k. And we need a, I guess, postfix sum. And we initialize that with 0. And here we will just update our postfix sum with whatever the energy, the element in energy is at position j. And we will have to update our result, right? So that's going to be the maximum between result and the current postfix sum. I think that is all we need. Well, okay, we need to flesh out the second loop. So, well, this range is, well, obviously we start at I, right? For j in range from I to the very first, well, the first index in the array. And we have to do -1 because the 2 is not inclusive in the range notation Python, and the step size is -k. I think that's everything we need. That would of n time and of 1 space. Yeah, it's of n time because, I mean, we have two nested loops here, right? However, because of the step size, they don't touch any elements twice. So every element is only touched once. That's why this is an O of n time. Just checking. So if let's go through an example with our code. So if we start with input energy, well, with this thing. So we loop over, we start from the back. So we start at 1. So I equals 0, 1, 2, 3, 4. I is 4. Our j starts at 4 and then takes step size 3 backwards. So we'll add 1 to our postfix sum. Then j becomes j minus 3. So then we add 2 to our postfix sum. It becomes 3. And each time we're increasing our result. And oh, this could be wrong. So because we can have negative numbers, our result can be smaller than, yeah, we can have results that are smaller than 0. So we should probably pick, I guess the minimum of the energy area is a safe bet. Would that be fair to say? The minimum? Maybe that's also not correct. Well, we know it's for sure it's the minimum. Well, result is going to be larger than the minimum of the last k elements in the array, right? So if we said like that, I think that should work. I think that's a safe thing, yeah, because remember, in example 2, we've seen the case where the minimum was in here. So if result is not in here, that means by adding any of the elements that come before it, result becomes larger. So picking an initial result from the minimum here is safe. And we could even simplify this. We don't even have to do that. We can just say energy -1. Because energy -1 is a potential result. We just don't know whether it's the maximum result, right? So yeah, that simplifies it a little bit. So let's run the tests now. Right, test cases accepted. Let's see if it passes all of the tests. Nice, cool. So yeah, that completes this daily problem. There's probably a way you can use like dynamic programming more explicitly. I mean, we're kind of using dynamic programming, but a lot of people, they use, I suppose, like they initialize an array with the results and all that, and then they optimize that to where you don't need the entire array. We one-shotted this, so this seems like a quite natural solution to come up with. Yeah, I guess that concludes this video.